Elon Musk just dropped official plans for Starship drone ship landings. But here's what's fascinating. SpaceX hasn't built landing legs since abandoning them in 2019. They don't have the massive drone ships needed, and V3 is still proving re-entry control after multiple failures. The EIS documents map recovery zones across 3 oceans, yet no hardware exists. So when does this transition from paperwork to reality? Let me walk you through the evidence, and the timeline might surprise you. Let's start with where Starship actually is right now. The EIS documents talk about drone ship landings, but they're describing a vehicle that doesn't exist yet in operational form. Early 2025 showed us the brutal truth. Multiple ship failures during re-entry, heat shield tiles burning through, loss of control during flip maneuvers. SpaceX improved by year's end, but these weren't minor issues. They were fundamental control problems that kill any landing method, whether you're aiming for Mechazilla's arms or a drone ship deck. What matters for timing is this. SpaceX needs consistent ocean landings first, then successful tower catches, before drone ship landings even make sense. The V3 design emphasizes aerodynamic improvements and thermal protection redesign, but emphasis in engineering documents doesn't equal proven flight performance. Based on Falcon 9's development curve, getting from works sometimes to works reliably took about 16 months of iterative testing. Starship is substantially more complex, which argues for a longer timeline, but SpaceX now has a decade of landing experience, which could compress it. My assessment: V3 needs minimum 12 to 18 months of validation from whenever regular flight testing begins. Now here's where the timeline puzzle gets really interesting. Landing legs haven't existed on Starship since 2019, when SpaceX committed fully to Mechazilla catches. Bringing them back isn't simple. The aft section houses up to 33 Raptor engines on Super Heavy, all the propellant feed lines, complex piping networks, and thrust structures. Foldable landing legs need internal mounting points deep inside this already packed space. You're looking at significant structural redesign, hydraulic systems, mass penalties that affect payload capacity. The engineering analysis alone takes months, then design iterations, manufacturing setup, and ground testing before anything flies. Then there's the drone ship fleet itself. SpaceX operates 3 platforms for Falcon 9, each roughly 300 feet long. For Starship, the EIS documents propose landing zones spanning the Indian Ocean, Pacific regions, Atlantic, and Gulf of Mexico. That's 5 operational areas, minimum. But here's the critical detail most people miss. A Starship-capable platform needs roughly double the dimensions of current drone ships. The landing thrust alone demands this. Raptor 2 engines generate landing thrust equivalent to Falcon 9's full liftoff thrust, and Raptor 3 will exceed that. We're talking several hundred tons of force concentrated on a deck surface. Building or converting ships of this magnitude runs on multi-year timelines in the maritime construction world. Has SpaceX started this process? There's no public evidence of shipyard contracts or platform modifications. That absence tells us something important about timeline realities. The Florida EIS filing requests approval for 120 combined annual launches from LC-39A and SLC-37. The documents explicitly mention drone ship landing as an option for some flights. Not all flights, not most, some. That word choice matters because it reveals strategic thinking. Drone ships aren't replacing Mechazilla catches. They're serving specific mission profiles. Which missions need this flexibility? NASA missions from LC-39A and Air Force national security missions from SLC-37 often require high-energy trajectories. When you're launching to geostationary orbit or beyond Earth trajectories, the booster burns substantially more propellant. Less fuel remains for returning to a fixed tower location. A drone ship can reposition itself downrange along the flight path, dramatically cutting the booster's return fuel requirements. This is exactly how Falcon 9 currently handles its highest energy missions. What the documents don't tell us is arguably more revealing than what they do. No specific dates, no hardware readiness assessments, no testing schedules. The EIS establishes regulatory permission, not operational capability. There's a massive gap between approved to do this and ready to do this. Understanding that gap is key to predicting actual timelines. This is where I think the timeline pressure becomes undeniable. Musk stated directly in 2023, "That's how we will land on Mars." He meant landing legs, and he wasn't speaking hypothetically. There will be no Mechazilla towers on Mars during initial missions, possibly not for decades. Landing legs are mandatory for planetary exploration, period. The same reality applies to NASA's Artemis lunar missions. Starship must land on the Moon's South Pole region. No catching towers there either. SpaceX must develop reliable landing leg systems whether they prioritize it or not. Their major contracts depend on it. Now, consider Mars mission windows. Optimal Earth-Mars transfers occur roughly every 26 months when planetary alignment is favorable. The next windows open late 2026, then 2028 and 2031. If SpaceX seriously targets cargo missions to Mars this decade, and Musk has repeatedly stated this goal, landing leg development can't be postponed indefinitely. Here's the forcing function. You don't debut critical hardware on another planet without Earth testing first. Drone ship landings provide the perfect testing ground. Real deployment under actual flight conditions, real structural loads, real stability challenges, but with recovery and iteration possible. If Mars cargo missions target even the 2031 window, landing leg testing needs to happen years earlier to allow multiple iterations and improvements. When I layer these constraints together, a realistic window emerges. V3 validation needs 12 to 18 months minimum from regular flight operations. Landing leg design through flight-ready hardware adds another 12 to 18 months, assuming preliminary engineering work has already started. Drone ship construction represents the longest lead time at 2 to 4 years for purpose-built vessels. But SpaceX doesn't need all 5 drone ships operational to begin testing. They need one platform in the Gulf of Mexico or Atlantic, close enough to Florida launch sites for initial attempts. That single critical path item changes the timeline calculation significantly. My analysis points to late 2026 through 2027 as the most probable window for first legs-equipped Starship drone ship landing attempts. That sounds aggressive, maybe unrealistic to some. Yet when you trace through the technical dependencies, SpaceX's historical execution speed on Falcon 9 drone ship development and the Mars mission forcing function, it's not impossible. It's challenging, absolutely, but within the realm of SpaceX's demonstrated capabilities. The real insight here isn't whether SpaceX will eventually do this. The EIS documents confirm that's the plan. The question is whether they can compress development timelines enough to make drone ship landings operationally relevant for their near-term mission requirements. Every month of delay pushes against Mars mission windows and Artemis contract obligations. That external pressure might be the most powerful timeline accelerator of all. So what's the answer to our timeline mystery? Based on V3 validation needs, landing leg development, and Mars mission pressure, late 2026 through 2027 emerges as the most realistic window for first drone ship landing attempts. That's sooner than most expect, but the evidence supports it. SpaceX isn't just filing paperwork, they're building operational flexibility that no competitor can match. This investigation shows us something crucial. Drone ships aren't a backup plan, they're strategic expansion. If you found this analysis valuable, hit that like button and subscribe to New Space Review for more deep dives into SpaceX's development. What's your timeline prediction? Drop it in the comments. I read every one. And if you want to continue this journey, check out the video on screen now about Starship If 3's breakthrough upgrades. Thanks for watching and keep looking up.